Bismillahirrahmanirrahim. Today we will start the first chapter for this book, that is Fundamentals of Database Systems, 7th edition by Al-Masri and Navadi. So the chapter number 1 is regarding databases and database users. This is the fundamental chapter, you can say the first chapter, which gives you a brief description of what database is, what are the basic definitions, what are the basic components of the database systems, who are the users, and the functions of databases, along with some other basic definitions. So this is your outline for this chapter, and we will go through with each of the topic briefly. So what is data, database, and DBMS? This is very important to know. Whenever we say data, it means that we are talking about certain facts which you want to store, which you want to record, which you want to save. Obviously, that fact is regarding a certain domain, or you can say a certain area or a field. For example, if we are in the university, we are dealing with the data which is related to students, data regarding the faculty, data regarding the courses which are being offered in the department. Similarly, if in the same manner you are interested in a bank application, then the data is regarding customer or a client or an account holder, the data regarding accounts and the transactions which happens in a bank. So what database is? Database itself is, you can say, is basically a structured, organized, interrelated set of data about a particular enterprise, and that is called a database. So whenever we talk about a database, it means a proper organized structure where you have the integration, where you have the interrelatedness, and where you have a proper structure for recording that data. And obviously, whenever we have database, we have access to that database also. And that database is actually managed by a software which is called Database Management Systems, normally termed as DBMS. And DBMS itself is basically a set of programs to access the data. So DMS provides us the complete functionality so that we can access the data, we can retrieve the data, we can process the data, and those DBMS can be developed by using any database software, such as Oracle, such as Microsoft SQL Server, or any other product. Database systems are used to manage collections of data that are highly valuable, relatively large, and obviously that has to be accessed by multiple users and application, often at the same time. For example, we have a national database of all our citizens. So once it is developed, then it is being used for all other application, related applications. For example, to validate the people who are interested to get a new SIM for their mobile phone, or if you go to a passport office for a renewal of your passport. So that application is being used. So obviously, the database is basically, you can say, once you build, you can use it anywhere, because once you have the data with yourself, then it's up to you that what type of applications you want to run on that data and how you utilize that data, which is there in your database. So modern database system is a complex software system whose task is to manage a large complex collection of data. So now we are not only talking about the data which is only in one or two formats. So with the passage of time, the complexity level also changes. Now we have to deal with all kinds of data. For example, at the same time, we are giving our biometrics. At the same time, we have pictures. At the same time, we have clips. At the same time, we have voice and all other kinds of data. So it means that data is of various kinds, is of complex nature. So it means we have a need a proper integration system or a management system. So the modern database systems provide you the flexibility to manage all kinds of data, and also gives you a platform where you can develop any application pertaining to any domain. Database touches all aspects of our life, agree, because it is related everywhere, because in any organization or an enterprise, we have to deal with data. Even if you want to save your own data, your personal data, you need a proper system. You put it somewhere, and obviously that data is being used anytime, anywhere, and it is required anytime, anywhere. So we need to manage that data. So we have various kinds of applications, including the traditional applications, normally called as classical applications, where normally we deal with numeric and textual databases. For instance, we are interested to have data of all students and their marks which are obtained in the last 3 semesters, 4 semesters. So that all data is normally a numeric or textual base, or you can might add a date type as well. So most of the time we deal with the numeric data. For example, we want to keep the data of, for example, the weather. So all those attributes which are regarding weather all gives us the numeric values. Maybe that is the humidity, or maybe that is the temperature, so on and so forth. So everything is in numeric. So traditional and classical applications, when we talk about, let's talk about accounting systems. We want to keep track of accounts of our organization, or we are dealing with inventory systems. So all these classical and traditional applications normally deal with the basic data types. But nowadays, um, the concept of database is really changed, because the people are now talking about multimedia databases. So it means not one media, but we want to design more than one media, in terms of maybe the biometrics, maybe the iris images, maybe the fingerprints, maybe the picture, so on and so forth. So it means we also dealing with voice notes, dealing with waves, might be dealing with clips, OLE objects, so on and so forth. So we are dealing with multimedia databases. We need to manage such applications. Let's suppose a media organization want to have such a database, so that they want to access all those resources which are there in their repository, and they need to access from their repository in a quick time. Similarly, geographical information systems, GIS based applications, where you are interested to have the location, and that data is regarding the location. So maybe you are interested to know the locations of various entities which are important in your system. You want to develop a GIS based systems for urban development. You want to develop a GIS application for your ambulance management, or maybe various other applications. Similarly, we are people are now interested to develop the biological and genome databases. We want to keep uh, the information of genomes which are being discovered of various species, and we want to store the various characteristics which are associated with this genome structure, and where we want to save the information about the structure itself, the growth, other related characteristics. Uh, Similarly, there are applications which are related to data warehouses, where we have various data resources, and from those various resources, we can obtain data, whatever we required, by applying various online applications or OLTP tools to access that data. Mobile databases as well, and we also talk about real-time databases where we have to provide the data on the real time, and that has been updated as soon as we enter that data. So sometimes we need real-time application as well. So obviously, the our main focus is on the traditional applications or classical applications, because we are dealing with the first course or the initial course of the database systems. And obviously, as we move on, we will see that how we can develop or how we can handle even the complex data. Basic definitions, if you just want to conclude, a database itself, it's a collection of related data. For instance, I want to have a database of my university or my department. So I need to develop a database, and it requires various kinds of data, which may be regarding the staff, which may be regarding the students' personal information, students' marks in various courses, performance in various courses, the faculty and the courses which are being offered in the department. So if I handle all that data, and I can integrate that data, then I can form a database. Data itself are the facts which are being represented or recorded, which have an implicit meaning. So obviously, data has to be relevance, or data has to be relevant, because if we want to have the data regarding a student, we need a relevant data. So that's for sure. So that is why it has an implicit meaning. Mini world, some part of the real world about which data is stored in the database. For instance, I just talked about the data regarding students or data regarding faculty. So it means I'm talking about the mini world. So mini world is my, you can say, a scope for which we want to have that database. For example, I just give you an example of student, faculty, staff, courses. So this is my mini world. So whenever we are developing such databases, we have to deal with the mini world. Either it's we are building an application for a specific bank, either we are building an application for a specific hospital, either we are building an application for any public sector organization, or so on and so forth. So we have to deal with that mini world, and we have to consider only those facts which are relevant to that mini world. Database management system, a software package or a system to facilitate the creation and maintenance of a computerized database. Also, we need a system. So that system itself is called Dbms, which itself is what? Is a software system. What that software system will do for you, it will provide you all the facilitation through which you can have your design your own user interfaces by which user can enter the data. User can also you provide them the accessibility, user can view the data, and also you can maintain the data, whatever the data is there. So it provides you a complete system where you have all that facilitation. So you need to develop that DBMS by using any database product. So it is always recommendable. So whenever you are building such systems, you need to have a specific database product, because the reason why we opt for specific database products, because they have a complete package. So they have all the important ingredients or components which are required for building such systems. Otherwise, if you do not use a proper database product for building database systems, then you need to develop your own, which is a typical task. And for professional organizations, it won't work. So database system itself is a DBMS software with data. Sometimes the applications are also included into it. So there are various applications you can see on this slide as well. That let's suppose talk about business. So there one aspect is banking, then there is an insurance, then there is a retail, transportation. We need to have a transportation system as well, maybe for ambulances, maybe for public transport, maybe the other vehicles which are on the road. We want to have the data. Healthcare, manufacturing sector, of course, manufacturing organizations, because it involve lots of data. So they have the ingredients, they have to develop the products, they have a price, they have a process itself, and obviously we have to manage all that information in the database. Service industries, which include might be the financial services, real estate, legal, electronic commerce, small businesses, they all require data, because without that they won't work. So real estates deal with the property, so the property itself has a data. That property might require a GIS based system or GIS application, or it may be without GIS application if it only describes the characteristics of that particular uh, plot or a particular house, maybe, or a property. So in education, I just gave you an example of a university, even for a school, for a college. Now it is also important in social networks, because on social networks we are dealing with the people, so lots of data is being generated through social networks as well. So that has an impact. We need to have that data. That data is being used, how many times you did this, how many times you did that. Okay, so environment and specific applications, of course, environmental and scientific applications also need a proper database that has, therefore, that has an impact. So we need to manage all that environmental changes, ecological changes which are going through. So if you even go through with the global organizations, you will came to know that there is data which is regularly being updated. So that is very important, as well as for various scientific applications, medicine itself, and genetics, personalized application based on mobile devices. So we can also develop some personalized applications. Normally, students develop their own applications for their projects, or even as a new product. So that also requires that data. All those applications works on that data. I will just skip this slide. I will describe this in the next part. Now here you can see a simplified architecture of a database system. It is very easy to understand this concept if you see this diagram. So whenever we say an architecture, architecture means that we are talking about components. So architecture normally deals with various components, and and the second part is that how those components are interacted with each other. So we have to have an interface between those components. So that gives you a clear idea that how it works. So on the top, you can see the user programs, users oblique programmers. So these are what? These are the database users. So in for any enterprise, if we develop such a database system, the users are there who will use it. For example, if I implement this in UBIT or in Department of Computer Science, the staff over there will use it. Obviously, the faculty over there will use it, and the students will also provide some sort of an accessibility. So you are the users. And who are the programmers? Programmers are a special type of users whose responsibility is to develop applications, to write codes, to execute codes, and to run an application on that particular data, or to generate a certain kind of data which is required in a given application. So there may be users, there may be programmers. What they do, they if they are ordinary users, they generate queries. If they are programmers, they write application programs. That is the difference. But both things actually access the data which is there in the database. So either you generate the query or the application program. Normally, we are talking about database systems, and normally we are talking about a relational database system. So in a relational database systems, that queries are being generated by using SQL. So normally users are being provided the SQL interface through which those users provide various queries. However, the SQL itself gives you a command line interface. So we do not give the command line interface to the users, ordinary users. Instead of that, what we do is we design forms for the users so that users can easily access the data, or they can easily write a query. And normally we provide them various options to provide such a query. So once that application program or query is being generated by the user or the programmer, the DBMS software component comes into play. And what it does in the first step is to process the query or a program. Let's suppose if a query is being generated, that has to be processed, and to process that query, obviously that has to be checked whether it is syntactically correct or it's semantically correct. When we talk about syntactic checking, basically it's based on as you know, it is based on the interpreter or the compiler. So if you have anything wrong, so that will be suggested to you. And the second check is the semantic check, which checks actually that whether that query access the data which is actually there, or it is defined in the same manner in the database such that it can be executed. So once it is processed, then in the same in the same you can say a component, a tree is being generated. A tree is what is the gives you the path how you will find out the data. And then once the tree is generated, then the software will generate an access path, and that access path will go into the stored database, because actually the data is stored physically on the drive. So that access path will be generated to find out where that data is being saved in the secondary storage, and that data is being retrieved. So here the concept of cache, buffer, and the activity of retrieving, because it takes time. So that is involved. And then similarly, that response goes back to the users in the same manner. So that is, you can say, a very simplified architecture. In this diagram, that architecture is explained in bit detail, and I will cover this in the next lecture. So what a DBMS facilitates: define a particular database in terms of its data type, structures, constraints. The most important facilitation of the database system is that in a database system, you give types, you define various types. You might define a varchar, you might define a character, you might define numeric or alphanumeric, or you might define a date time or a timestamp, or a binary attribute or OLE object, so on and so forth. So you have that freedom to define the data types. Structures itself, structures in terms of relational database environment, that the structure might be a table. You have that facility to create table or tables. You can create views, you can create indexes on various attributes of those tables. And constraints, so we have various kind of constraints in the database as well. So if you have a proper DBMS, you have that facility to create those constraints. Those constraints might be the user defined constraints. Those constraints may be the declarative constraints. Those constraints may be the key constraints, so on and so forth. So there are various kinds of constraints. So construct or load the initial database content into secondary storage medium. So whenever you run such an application, that database content is actually stored in the secondary device. Then you have the facility to manipulate the data. So in manipulation, actually three things are there. Number one is insertion, number two is deletion, and number three is modification. So these three processes are there, and you can see in the modification as well that insertion, deletion, and updates to its content. Retrieval means in retrieval, what you want to know, only the information you might want to know. For example, I just want to run a query to to retrieve that information, that is there any transaction carried out yesterday, or what is the balance of this account after this particular transaction. So these are simple query. Or even we are interested to generate reports as well. Reports are considered to be an output of a system. So for any domain, if we, or an application, if we develop database systems, we also develop reports. For example, in a department systems or a university system, we are interested to generate the student's transcript. So that transcript is a predefined structure which is being designed, and which is being generated with the help of any DBMS tool. Or there are many other examples of such reports. Processing and sharing by a set of concurrent users and application programs. So that data is being used or being shared among various concurrent users, and that sharing and processing is done parallelly, not sequentially. That is again the facilitation of this DBMS, and therefore multi-users accessibility is allowed, and obviously concurrent access is also required. Other DBMS functionalities might be the protection or security measures to prevent unauthorized access. Yes, every database systems have this mechanism to prevent from any unauthorized access. So normally we have a system where we can generate user IDs and passwords, and we can also assign rights to specific people or groups, such that nobody can access such data if they are not authorized. So normally a strategy is being built, and that policy is being implemented by any database administrator who is there. Presentation and visualization of data is also important, because nowadays we are not only interested in tables, or we want to see a huge spreadsheets to find out what is happening. Rather than that, now the managers are more interested to generate various kinds of visualization in terms of charts, in terms of graphs, and maybe in terms of 3D graphs and other tools which are now integrated with such systems. So it gives you a very clear idea that how the information is being represented, and that will help you to make decisions. And obviously the maintenance is also required for any such systems, because no system exists for the lifetime. So we need to apply certain methods by which we want to maintain that data, which maybe includes the cleaning, which might include the cleaning of data which is there for a longer period of time, or which might create problems for the system. Application interact with the database by generating queries and obviously transactions. So queries normally are of two types. One is everyday queries, where normally we generate various kinds of queries, and the other kind of queries are those queries which we have to execute on a specific point in time. So those queries are normally generated and are there, which we only have to execute. There is no need to write it again, because that information is required, might be daily, might be hourly, might be monthly. So transactions that may read some data and update certain values, or generate new data and store that in the database. So transaction itself in database system is considered to be a bundle task, a task which is being carried out by various activities. So if you combine all these activities together, let's suppose those activities will update the data, then the data is being updated or stored in the database. So let's suppose I have run a transaction on all those employee data, and I've tried to find out how many employees have been working for the last 10 years and in more than three projects. and the project worth is, for example, is $5 million. And if this is the case, all those employees salaries are being upgraded with 20% advance. So this is a transaction. So transaction involves various tasks, various steps, various activities. So if you can say it is bundled. So if any one of the activity fails, the transaction normally fails. Okay, and once it is done, it is committed. It means that change is being done in the database system. So mini world example here, the example is regarding a university, and the entity is what the student course, the sections of those courses, the departments, and the instructors, normally called teachers. So sections are of specific courses. So that is my mini world relationship. So in this mini world, we have these things. So you might interested to develop such an application for your own university. Then you have to see that how your university works, what type of important you can say the entities which are there. So it might be similar, but it does not mean that you have to make a replica of this, because it basically based on that mini world. So there are various banks. If you develop application for a bank, it might have a similarity with the other bank, but not necessarily that is 100% similar. Similarly, there are various hospitals. If you want to develop such an application for a hospital, you might have a similarity among them, but you might have various differences. And therefore, that mini world is important. So, whatever the requirements you have, actually, you have to translate those requirements into the database systems. So, here we have defined the concept of a section student course structure and so on and so forth. And you can see now just a simple database, and you can see there is some information in the course table, there is some information in the section table, there is some information in the grade report, and there is some information available in the prerequisite. So these all tables just show you that how data is being organized, or data can be accessed, or data can be retrieved if you have a proper database system. So when we talk about a relational model, in the relational model, always remember that we deal with the relation. And in the relational model, the relation means a table. Relation itself is a structure. On this slide, you can see on the right side that you have a picture of an individual whose name is Scott. Normally we call it EF dead cod. So dead cod is basically, you can say, the person who basically you can say gave the idea for the first time that how data can be organized or structured in the relational format. So in the relational format, the structure, the formal structure for recording a data is a relation, and he described that relation is like a table, not a table. It's like a table. So if you see this example on the slide, there you have a table. That table includes four columns. All those four columns representing four attributes. ID is one attribute, the name is another attribute, department name is another attribute, and salary is another attribute. And on the other side, you have a row. For example, 2, 2, 2, it's just a dummy data. So 5 times 2 is Einstein, his department name is physics, and his salary is 95,000. So this represents a row. And in our method, in our representation, or in a relational system, or in a relation, that row is normally called as a record. So in a table, we have attributes, columns, and there are rows normally termed as records, and they are also called as tuples, or some people say tuples, no problem, whatever the pronunciation you want to use. So these are rows, records, or tuples, and there we have four columns. The number of columns represents the degree of the relation. So if I just ask you what is the degree of this relation, so you can respond me that the degree of this relation is 4 because we have 4 columns. And the number of records in a relation represents the cardinality of the relation, or the cardinality. Here, for instance, how many records we have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have 12 records. So if I say what is the cardinality of this relation, the answer will be 12. So that is the way we record the data, and that is why you have seen in this example that all this information is represented in various tables. As you can see the course table, where the attribute is course name, the other attribute is course number, the third attribute is credit hour, the fourth attribute is department. And there are 4 records. Let's say take the second record, data structure CS3320, credit hour 4, department is CS. So that is the basic concept which you have to understand. So what are the main characteristics? Number one, self-describing nature of the data. So that where we have that the important characteristic is about a catalog, Dbms catalog. Catalog itself is also called as data dictionary. So that whenever you are using such systems, they also gives you the metadata, that is data about the data. For example, here you have in the database you have these 4 tables. So in the database they will create a table itself which gives the information that how many tables are in the database, how many attributes are there, how many primary keys are formed, which I will discuss later on. So that information is generated by itself by the database, not by the user, to maintain information about the data. So that is why it is called data dictionary or a metadata. Insulation between programs and data. That is a very important characteristic of relational database systems, and that is why that is also called data independence. So previously, all those systems which were developed, they they actually in those models, the data and programs are intermingled. So once you have any let's suppose if you want to insert a data, you have to go and change the application and the programming code, or you have to write a coded instruction. If you want to update the data, you have to write the coded instruction, because the application and the data are intermingled or mixed. But in relation environment, now it is separated. Now we have a data independence, so that has no impact on the data. How you describe the data, how you define the data, how you manipulate it, you'll not require to go and modify the application. That is also an example of the metadata which I just given to you, that how many relations you have, how many columns you have, for example these column names, what type they have, so on and so forth. So all that information is actually not generated by the user, by itself is a catalog. So who actually take the help from the catalog? So the application take help from the catalog, and also let's suppose if I am the developer, if I am the person who is responsible for this database application, I can also access that information to understand that how that database is being built, what is the structure of the database. So that really is a, uh, uh, really good for the people who are working on new applications. Data extraction, yes, you can form a data model. And when I say an abstraction, abstraction means that what data you want to keep and what data you don't want to keep. So it's up to you what data you want to define. Let's suppose here you opted for, just take an example here. For the course, you just opted for course name, course number, credit hour, and department. So in your opinion, that is the abstraction. So that is the model which you have formed regarding course. So somebody might say that there are other attributes as well which we may describe the course, but according to you, no, this is enough. So you only require these attributes. That itself is a process of an abstraction. Multiple views of data, yes, user allow multiple views of data, and at the same time various users can see the various views. So that is the beauty of such systems. And that data is also shared in a multi-user transaction processing, or you can say to the multi-users for transaction processing, or the concurrent user can retrieve from and update from the databases. That it means that various users at the same time can process that data, they can update that data, and there is no conflict among various users, and that is being managed by such systems. There are various kinds of users. Normally, the users are being categorized in terms of application developers and the database administrators. So, normally, there are two basic categories in terms of users. If you take the ordinary users, as a separate category, so there is an ordinary user, those users who only access that data. Normally, let's suppose if I have developed an application for a hospital, there are doctors who will use that application, there are medical staff who will use that application, there are finance and accounting staff who will use, there are ordinary users. But instead, apart from those ordinary users, there are a special type of user. For example, the people who are allowed to change the security levels, people who are allowed to write an application program. So we have application developers and the database administrators. So normally in database systems, we have two tracks as well. One is called the application track, one is called the management track, so or administration track. So once you start your career in database systems, later you can decide on which path you can go. That is the concept of database administrator, who is responsible for authorizing access to the database. So normally he is the person who implement that policy, and that creates the checks, and he's responsible for all those activities which are being carried out. And one category is called the designers or the developers or the application developers, responsible to define the content, the structure, the constraint, and the function. For example, they are responsible for building user interfaces. They are responsible to develop various reports or generate reports. They design forms. They come out with various to define various structures and so on and so forth. So that is the responsible for the administrator. So there are various kinds of users as we have discussed. No need to go into the detail. What are the advantages we have in such system? Number one, once we have a proper database system, we can control the redundancy in the data storage. What is redundancy? Is the repetition of the data. So because the repetition of data creates problem, if we have many copies of the same data, then it is difficult to update it, difficult to manage it. So once you have a proper data system, then there is no duplication. Okay, and once there is no duplication, it means you the data will remain consistent. So if data will become inconsistent, then there is a reliability problem. So that is the advantage of the database system. There we can control the redundancy, restricting unauthorized access to data. Only the DBS staff uses privileged command and facility. So we can easily implement a policy by which we can restrict the unauthorized users to access that data, because even within the organization you have restrictions. You can access some data, but you cannot access some data. Number one. Number two, sometimes only you can read the data. You are not allowed to insert the data. Sometimes you are allowed to insert the data, but you are not allowed to update the data. So normally in the organization we have various levels. So we make those policies with respect to groups, with respect to levels, and then we implement that policy so that only the required people can access that data. That provides us the persistent storage, means that once the data is being saved, that is saved permanently in the system. And it also provides all those structures. provide optimization of queries means the queries which are being generated are the queries of least cost, so that we can quickly retrieve the data, because if the retrieval is slow, then it is not acceptable. The clients might or customer might make a complaint. Oh, we it's taking time, so it is difficult to access the data. So we need a quick response to the people. Backup and recovery, that is another important advantage we have. So once we have that data, we can take a backup. Not only the backup on the same site, but we can also take a backup on any other site remotely. And because at any point in time, there might be a natural disaster, or there may be a man-made disaster, or even sometimes a threat from any outside entity. So in that case, you need to have a backup system, because if you don't have a proper backup and recovery system, then you will not be able to provide services to the people. And if you are not be able to provide services to the people, then you might lose those customers and you might lose your reputation. So we can also enforce the constraints as we have discussed, and various other advantages we have. And once we have the database system, it means we are enforcing the standards. And standard means that the standards which are being described for storage, for definition. So it means that it is accessible everywhere. So it is not like that you have your own standard and it is not recognized by globally. So that will create a problem. So whenever we are building such application, these are standardized. So it can be portable, it can be interoperable, and it is acceptable everywhere, and it can be run on the same machines. Reduced application development time, obviously that application time is being reduced. Flexibility to change data structure, yes, we have that flexibility. We can change the data structure. I can just quickly go through with some of the previous models. That is hierarchical model and the network model, that is prior to the relational model, which basically are not, you can say, provide us the data independence, and there are lots of maintenance issues in that. Therefore, those models, when replaced by the relational model, now since then it is the most popular model for building such systems, and which was introduced by COT, as we have discussed in the previous slides, and now it is being implemented in all the products. We also have an object-oriented database system that is also there, that is called Dbms, which is purely object-oriented. And apart from this, we also have the object relational database system. Means primarily it is relational, but it allows you some of the object oriented aspects, such as abstract data types, to you can define. And with this I conclude this lecture, and I hope that you have understood the basic concepts of database system, and that will help you to comprehend the importance of database systems. And obviously that information is linked with the next lecture. Inshallah, I will go through with the next lecture in the next week, and I will update this information on my channel. Thank you so much for listening, and I will wait for your queries and response. Thank you so much.